Good morning, everyone. This video we are going to cover section 10.4, equations in quadratic form. For example, now we are looking at an equation x to the power of 4th minus 10 times x squared plus 24 equals 0. Obviously, this equation is not a quadratic equation because by definition, a quadratic equation refers to a polynomial equation with degree 2. But if we look at this equation, the biggest exponent on the shoulder of x is 4. Okay, so this equation actually is a polynomial equation with degree 4. It's not a quadratic. However, this equation is a quadratic in form. Then what kind of equation is quadratic in form? One standard form that we can identify to be a quadratic in form is the equation right hand side is 0 and the left hand side is a trinomial. You see 3 terms, and the leading term has exponent twice of the exponent in the middle term. So this one has all the features that we just mentioned. This polynomial equation is in the standard form already. Right hand side is 0, left hand side is a trinomial, 3 terms. And the leading term has degree 4, has exponent 4. The middle term has exponent 2. And the 4 happens to be twice, this is very important, twice of the middle term exponent 2. 4 is twice of 2. For that reason, we identify this equation is a quadratic in form. Then how do we solve an equation if the equation is a quadratic in form? We are going to apply substitution method. Okay, substitution method. So we are going to bring in a new variable u, or you can choose your favorite letters. I use u, or you can use t or y, whatever you prefer. I let u be x squared. Okay, and then if in this equation I square both sides, if I square both sides, and then what we would have? So then we would have u squared equals x to the power of 4th. 2 times 2 equals 4th. Is that clear? And let me erase this part. If we let u be x squared, then u squared would be x to the power of 4th. Then I'm going to go ahead to write the equation. The original equation is in variable x. Now I'm gonna rewrite the equation in variable u. Okay? So everything in x, we're going to rewrite it in something in u. So now we look at this equation. We see x to the power of 4th first, right? That is u squared. Yeah, then the original equation will be written as u squared. I copy minus, copy 10 coefficient. And then when I see x squared, that is u, right? And I copy plus, copy 24, copy equal, copy 0. You see that? Through this substitution, I rewrote original equation, which is in x, as an equation in u. And this new equation in u is a quadratic equation. Okay, it is a quadratic equation because the degree, the exponent, the biggest exponent on the variable u is 2. That is quadratic. If you recall, we have learned multiple several different methods to solve a quadratic equation. So now we are going to solve this equation for u. Okay, now we are going to solve this equation for u. You can either apply solving by factoring, right? That's one method we have learned. We also have learned square root property method, and we have learned completing square method. We have learned the quadratic formula method, right? So either method you prefer, any method you prefer. In this case, I'm going to factor. I'm going to solve this equation for u by factoring because the leading coefficient of this equation is 1. Okay? And the constant is 24. The middle term coefficient is -10. I can see I need the two numbers, -4 and -6. This is my shortcut method. We have learned this method from the very beginning of this semester, okay? Yeah. Because -4, -6 multiplied to 24 positive, add up to -10. So we are able to rewrite the left-hand side or factor the left-hand side as u minus 4 times u minus 6. If you are not sure, you will see, you go back to the original equation, the left-hand side of the equation, okay? And then by the zero product property, you would know either u equals 4 or u equals 6. 4 happens to be the opposite of -4. 6 here, the other solution for u, is the opposite of -6. But are we done? Should we finish at this point? No, we're not done yet, because we are solving the original equation for x. Now we only have the values for u. U did not exist at all from the very beginning. We made it happen. We created this new variable to simplify the original equation. Yeah, we would have to solve for x. We need to find the values for x that satisfy the original equation, okay? So now we're gonna go back. We're gonna use the same substitution. This is the substitution. Let me pink it. U equals x squared. That's the substitution we use, right? Now we're going to use it again. Earlier, when we use it, we go from x to u. Now when we use it again, we're gonna go from u to x. So here, u is x squared, right? Because u equals 4, so x squared equals 4. Because u and x squared equal. Or u equals 6, then x squared equals 6. You see what I'm saying? So we apply the same substitution. We go back from u to x. Yeah, because we already have u equals 4 or u equals 6, and u equals x squared. Then we have x squared equals 4 or 6. And now we solve this equation. What method are we going to apply? Square root property. This method we have learned earlier in previous section. Square root property. Okay, because x squared equals 4, we have x equals plus minus square root of 4, which gives us plus or minus 2. Or the logical connective, be very careful. You're gonna copy it every time you move down. You move forward for the solution with the solution. And here, x squared equals 6. By the square root property, we have x equals plus or minus square root 6. Okay? Yeah, let me highlight the solution. We found 4 solutions for the original equation. Original equation is a polynomial equation. The polynomial has degree 4. The number of the degree is 4. And it happened to be the same with the number of solutions. We did find 4 solutions in complex number set. Of course, that's an extra. You don't have to know that until you take the advanced algebra or pre-calculus. But it's still good to know. In complex number set, if the polynomial equation has degree 4, then in a complex number set, you should have 4 solutions. We did find 4 solutions. So we can make a conclusion now. Thus, the solution set is a set containing 4 solutions. There are 2, -2, root 6, -root 6. Is that clear? That's how do we solve an equation quadratic in form. That's how do we solve an equation quadratic in form. I already showed you how do you identify if an equation is quadratic in form or not. Yeah, a certain characteristics has to be satisfied. Right hand side is 0, left hand side happen to be a trinomial. The leading exponent is twice of the middle term exponent. Then you can go ahead to apply a substitution, bring in a new variable u, rewrite original equation as a quadratic equation in u. That's how we handle it, okay? Yeah, be flexible. But this is very basic. This problem is very, how do I put it? Very typical, very typical. Let's see another one. It's also typical. X to the power of 2/3 plus 6 times x to the power of 1/3 plus 8 equals 0. Let me rewrite this 8. Alright, so you are looking at an equation. Obviously, the equation is not a quadratic equation. It actually is a radical equation. We have learned the formulas, right? So this actually is a cube root of x squared plus 6 times the cube root of x. The radicand of the radical contain variable x. So technically, by definition, this equation is not a polynomial equation at all, not a long quadratic equation. This equation is a radical equation. However, this equation is a quadratic in form. Looks, it could from just look at the appearance, we can say the equation is a quadratic but in form. Right hand side is 0, left hand side is a trinomial. The biggest exponent on the shoulder of x, the leading exponent 2/3, happen to be twice of the middle term exponent 1/3, right? We all know 2/3 is twice of 1/3. So the characteristics, the features that I mentioned are satisfied. So we identify this is a quadratic in form. Then how do we solve it? We use the similar idea. We use the same idea. We use the same process to solve this equation. We are going to apply a substitution. Okay? Yeah, I'm gonna apply u again. We're gonna create a new variable u. This time I'm gonna let u be the variable part in the middle term, which is x to the power of 1/3. Alright? Yeah. So we do the same thing. If we square both sides, we would have u squared on the left equals x to the power of 2/3 on the right. U squared equals x to the power of 2/3. Did we do the same thing earlier? Yeah. Okay, so the original equation could be written as when you see x to the power of 2/3, that is u squared, plus 6 when you see x to the power of 1/3, that is u, plus 8 equals 0. This equation is a quadratic equation in u. Okay, yeah, we're going to solve for u first and then go back the values of x. So whatever the method you prefer, I'm gonna factor again because it's so simple. We can tell the two numbers, the two integers, are 2 and 4. Because 2 and 4 multiply to 8, add up to 6. So we are able to factor the left-hand side as u plus 2 times u plus 4. Okay? And again, by the zero product property, we have u either equals the opposite of 2, which is -2, or the opposite of 4, which is a -4. So far so good? Yeah, quadratic equation. We have learned like several different methods to solve a quadratic equation. Now we have the values for u. We're gonna go back to x. Again, we can apply this substitution. We're going to replace u with x to the power of 1/3. So we have x to the power of 1/3 equals -2, or x to the power of 1/3 equals -4. We are solving for x, right? Yeah. So this is a very simple radical equation actually. We want to isolate x, then we need to get rid of the power 1/3. How do we get rid of the power 1/3? We are going to cube both sides. We are going to cube both sides. Or this one, the same thing, cube both sides. Then we would have on the left the cube cancel out or reverses 1/3. So we would have x by itself on the left hand side. And the right hand side, be very careful. What's the cube of -2? Use your calculator. You would have a -8, okay? Not a positive. Or this is the same thing. 3, 1/3, they cancel out. We have x by itself on the left equals -4 to the power of 3. Cube of -4, it gives us -64. Use your calculator. All right? So we have the solution now for x. Yeah, we can make a conclusion. Thus, the solution set of the original equation is a set containing two solutions. They are -8 and -64. By the way, which number is smaller? -64 is smaller, okay? Yeah, because both of them are negative. But it doesn't, it's not really related to this problem though. Is that clear? So let's move to number 3. Y to the power of -2 plus y to the power of -1 minus 2 equals 0. All right. So let's see these problems. This problem. Y to the power of -2 plus y to the power of -1 minus 2 equals 0. We need to be very clear. The original equation is in y. So the goal is to solve the equation for y. Okay? Yeah. Obviously, this equation is not a quadratic because, all right, so now let's rewrite the equation. Original equation is in y. When we see y to the power of -2, that is u. The left-hand side, 2 times u are the two numbers we were looking for because they multiply to -2, add up to +1. Either -2 or +1, okay? -2 is the opposite of +2. 1 is the opposite of -1. Because we talked about this before, if you move Let me see if I can move it. If you move, no. If you place a -2 right here, -2 and a +2 add up to 0, then you would have a true statement. Means this number satisfies the equation. Same thing with this one. Okay? Are we done? No. We need to solve for y, right? Same thing, we are going to go back. Earlier we go from y to u. Now we are going to go from u to y. Use the same substitution again. Because u equals y to the power of -1, so we're going to replace u with the y to the power of -1 here, equals -2, or u equals y to the power of -1 equals 1. Okay? And how do we solve for y? You have different methods. How about I use different methods to solve the two equation? So this one, on the left, I'm going to raise both sides to the power of -1 on the left. And on the right, how do you understand this? -2, another one, this one, y to the power of -1 is 1 over y. Think about the reciprocal of 1. Yeah, you can either apply your result. You can put in y equals 1. 1 to the power of -1 is 1. 1 is 1. Here the same thing. The reciprocal of 1 over -2 is -2. Okay? So we finish this problem, we can make a conclusion. Because we are solving the equation for y, right? You can make a conclusion. Therefore, the equation has two solutions. Well, the solution set of the equation is a set containing two values, -½ and 1. The original equation has two solutions. Let's move forward to number 4. X plus 1 to the power of 2 plus 8 times x plus 1 plus 7 equals 0. Okay. Well, if you look at this problem, it's different from the previous 3 examples, right? But this example, this equation, is also quadratic in form. It is actually a quadratic if you for u here, distribute here, and you reorganize this equation, you would see a quadratic equation in x. But however, you can look at this equation in a different point of view. You can actually see that we don't have to FOIL. We don't have to distribute. We could apply a simple substitution. Yes, I read this word for every example, right? Quadratic in form. We could apply a simple substitution. We could let u be x plus 1. Okay? Then the original equation could be written as, you see what is this here? Inside the parentheses, we have x plus 1. That is u. So the leading term actually is u squared. Copy plus, copy 8. When you see the parentheses, x plus 1, copy equal, copy 0. By using a simple substitution, we rewrote original equation as a quadratic equation in u. I would say that is simpler than FOIL here, distribute here, and combine like terms, reorganize everything. This is simpler. Now let's solve this equation for u. Factoring method again. You can tell because it's pretty simple. The two numbers are going to be +1 and +7. 1 and 7 multiplied to 7 add up to 8. U either equals -1 or u equals -7. -1 is the opposite of +1. -7 is the opposite of +7. And now we go back. for some people, this is still better than foiling and distributing. Now we go back. We have the same substitution, right? Yeah. So we're gonna go back x. U equals -1 because x equals -1 or x plus 1 equals -7. And solve this linear equation. Move 1 over. We have x equals -2. You move 1 over, you have a -1 here. -1 minus 1, -2. It's pretty simple. Same thing, 1 over, you have x equals -8. You can make a conclusion. So therefore, the original equation has two solutions. They are -2 and -8. Is that doable? Yeah, so after repeating the same idea, you should see that what is a quadratic in form? What is an equation quadratic in form? Okay. So we're going to skip number 5 in the notes because it's kind of like a beyond the scope. In example 6, in the notes, yeah, the last one. So let's see. This is a 2 plus 1 minus x all over x plus 1 equals x minus 2 all over x plus 6. This equation actually is a rational equation. Yeah, why would we have a rational equation in this section? Because once we eliminate the denominator, we would see a quadratic equation. So we put this example here. Also a good chance for us to review the procedure to solve a rational equation. Do you remember the 5-step procedure? Step 1, find the restriction. X cannot be -1, x cannot be -6. Why make this denominator be 0? -6 would make this denominator be 0, right? So we have to exclude -1 and -6 from the common multiple of those two binomial is their product, x plus 1 times x plus 6. Okay, what's the 1, 2, 3, 3 parts in the equation? Each single part, we multiply each single part by the least common multiple. So let me write it here. The first by the least common multiple. So let me write it here. The first part multiplied by x plus 1 times x plus 6 times x plus 6 plus the second part 1 minus x all over x plus 1. I would put a parenthesis. It doesn't hurt, then it will only make this. We wouldn't have any denominators anymore. So this is 2 times x plus 1. 3 foils 2. You're going to FOIL this one. So when you FOIL, you have x squared plus 6 here. The equation be 0. On the problems in the notes and make an appointment with me. And I hope to see you soon in Zoom. Thank you for watching. I'll see you next section.